Alright, so today we're looking at combined transformation of trigonometric functions. So we're still using the intention of the knowledge in translating and dilating different trigonometric functions. So we need to be aware of the change in amplitude, which is a vertical dilation, a change in the period, which is a horizontal dilation, a change in the center, which is vertical translation, a change in phase as a horizontal translation. Alright, so it can be broken down as if you got y k sine a x plus b plus c, the amplitude's k, the period is 2 pi, the phase is b, and the center is c. Same thing goes for cos. Obviously with tan there is no amplitude and the period is pi. Alright, so we want to find the equation of the transform function of y equals sine of x. If it's dilated with a scale factor of 5, you're going to get y equals 5 sine x. Now we want to horizontally dilate it with a scale factor of a third. You're going to get y equals 5 sine 3x. If you're going to vertically translate it 6 units down, that means the center changes. And if we're going to horizontally translate it to 5 units to the left, it means the phase changes. And we were going to the left, so it's going to be plus 5. And you get that. Okay. We want to sketch in the domain of negative pi and pi, so from here to here. Okay, so what I have done is I've drawn the normal sketches of y equals, for this example, sine of x. Okay. If I apply the amplitude first, it goes from now from 1 from 1, negative 1 to 1, it goes now to negative 3 to 3. Okay, and now it's going to be 2x. It means that we're going to have a period of a half. Yeah, so currently the period happens between here and here. We're just going to halve that. So it's going to happen twice in this section. Yeah, so what's going to happen is we're going to get this. Okay, and as I'm going from negative pi to pi, that's all I have to do. And then in an exam, then I could rub out all the pencil markings. Okay. So here we've got y equals 2 tan x over 2 plus 1. So this 2 factor isn't going to make it much different, except that we're going to get larger, some larger values. Okay, it definitely translates the function up by 1, which is why I have my center now here at 1. Okay, so I could do that. Okay. It does say I have, instead of it happening in a period of pi, it's going to happen in a period of 2 pi. So there's my asymptote, so it's going to stretch going to happen there. Alright, and I'll do this in maybe in red. Okay, so what's going to happen is I'm going to get that type of function happening at y equals 2 tan x over 2 plus 1. Alright, so in the last example we've got f of x negative 2 cos 3 of x. So remember the negative 2 won't, because it's an even function, it won't flip it on against the y-axis because it just will create the same thing. But it does stretch it from 2 to 2, so we're going to get something like that. Period happens between 2 pi, and now it's going to happen in 3. So we're going to cut this in thirds. Okay. So it means that it wants to create one pattern there, and that's actually pi. One pattern there, and a bit of a pattern here. Okay, and that's what you'd get. Okay, thank you very much.